Yeah, I mean, I think the biggest problem that we face as a civilization is conservation of energy. How do I conserve energy over time? And that's the inflation and the degradation problem. Um, a secondary issue is how do you move energy through space? The transactional problem. That's kind of tactical, but the strategic issue is what's the half-life of your energy, right? If I give you food in a container and it's good for like a day, well, you got to eat it in a day. How do you store food for a decade? It's a challenge, right? And if I give you energy and the half-life of the energy is 3 years, then you can only plan with a 3-year time horizon. I think when you have energy in the form of money, right? Money is monetary energy, it's economic energy. So if I have economic energy and I'm storing it in a fiat currency that's hyperinflating, that means that the half-life of the energy is 1 year. If the currency is inflating at the rate of 7% a year, the half-life of the energy is 10 years. If I put that money into gold and gold's inflating at 2% a year, the half-life of the energy is 35 years. If I put the money into a building and the building has a useful life of 100 years, that's long. I mean, no building will probably last 100 years without serious maintenance, but let's just plug it in just for grins. Well, so the half-life of the energy is 50 years. In 100 years, the building's gone. So what if I wanted the half-life of the energy to be 1,000 years or 10,000 years? How do I make something last forever? That fundamentally, the real issue with the human race is how do I make something last forever? How do I achieve immortal life? If I want something to circle the globe forever, I have to put it in orbit. If I get it almost in orbit, it crashes to Earth, right? Yeah. Almost in orbit is not in orbit. If I get it in orbit, it'll circulate a circle around the world forever. But if I get it out of orbit, if I can reach escape velocity, it'll circle the sun forever. And maybe if I beat the sun's escape velocity, it'll circle, a galaxy forever. So how do I conserve energy or how do I propagate energy forever? And Bitcoin is a solution to this problem. Paper money isn't a solution to the problem. Land and buildings aren't really a good solution. Gold isn't a good solution. And so I do think it's the idea that you can capture a set of energy and hold it forever, right, is a profound idea. And you can, it's not so different than saying, what if I wanted to build a city and I told you that the rock you're building the city on was only going to sink at 1 foot a decade? Okay, well, if Venice was sinking at 1 foot a decade, where does that leave us? Now, 1 foot, 100 years is still a bit of a problem. I mean, you lose 2 or 3 feet over 300 years and you're underwater in some places. So I really need something that's not going to deflect. It's not going to move, not 1 inch in 100 years, right? And if we look at things that advance the human race, steel's an example of a low deflection form of metallic energy. The difference between building a building with steel and building a building with clay or wood, right? Or, fill in the blank, right? Some other material, it's pretty profound. And building a city on granite or schist versus sand or swampland is pretty profound. Building an economic system, a company, a country, an institution on Bitcoin, as opposed to on Venezuelan bolivars, right? How long is your company going to last on a currency which is hyperinflating, right? Not 5 years. How long will your company last built on a currency like the US dollar? You said the US dollar lost 99.5% of its value over 80 years. That doesn't work as a foundation, as a balance sheet. And so Bitcoin Bitcoin represents, a liquid, fungible, synthetic asset that you can use to build a balance sheet. If you're a family, a company, a country, you can move it anywhere, right? It doesn't degrade, right? The maintenance cost is lower than any other form of asset. And if you know that you're building on a firm foundation, you can look out 100 years or 1,000 years. And, that's a profound idea. And so electricity was it's a profound idea, how I move energy efficiently, right? Over wires, over copper, using electromagnetism. But now there's this concept of digital energy, and people think, well, what is it? I don't even believe it is. What? Well, I mean, I could put $1 billion, on one end of the planet, convert $1 billion of fiat currency into $1 billion of Bitcoin, move it to the other end of the planet in an hour, and convert it back into Japanese yen and convert that into electricity and electrocute you with it, or convert it into, mechanical energy, or convert it into cars, or convert it into buildings, right? $1 billion moving over a wire becomes whatever you want it to be. And what is energy? Energy is matter. Matter is energy. There is conservation of energy. Matter is low frequency energy. You slow down energy and you get steel. You speed it up. I set things on fire, I take a piece of wood, looks like matter. I set it on fire and it becomes light and heat. What happened to the wood, right? All of these are just transformations. And the human race really hasn't really had the ability to transform energy into digital form. And once you do it, you realize that it's profound impact on the concept of property. What if I could have digital property? What is property? Property is low frequency money. What is money? Mid frequency energy. If I have $1 billion and hold it for 30 years, it's digital property. If I could put it in a building, then it's physical property. I could put it into Bitcoin, then it's digital property. What if I speed it up a bit and I pay for your coffee with it? Now it's like digital money. What if I speed it up a lot and I do 100,000 transactions a minute with it? No, it's digital energy, right? What's the difference, right? They're just different frequencies, vibration frequency, right, of energy moving through a medium. And the world doesn't quite understand that yet, and you can't blame everybody for not quite understanding that. The human race had hundreds of thousands of years to figure out fire, right? How long did we spend trying to figure out bronze, iron, and steel? A while. How about explosives? What could go wrong?
We're still learning about those.
What could go wrong? A bit. How long does it take to figure things out? Air power, sea power, land power, nuclear power. Arguably, we still haven't figured out nuclear power, right? Like the Germans shut down their nuclear reactors. Okay, but on the other hand, the United States won a world war with nuclear power, right?
Fusion's been 10 years away for half a century.
So the human race is moving forward through channeling energy. Bitcoin's just the latest chapter in that story. It's what if I could take $1 billion worth of electricity and put it in the palm of my hand, send it anywhere on Earth, store it for 100 years and not lose any of it? That's a pretty profound idea. I think that the key to advancing this is examples. We need to build it into technology. Like when Cash App built support for Bitcoin, that was this big step forward. When they built support for Lightning, a second step forward. When Cash App lets you move 1 Bitcoin from me to you for free on the Cash network, that's the layer 3. It's the third step forward, right? So here's big idea, right? Bitcoin's got $800 billion worth of energy on the main net on the level 1. You can move that energy in minutes for dollars.